So what are atoms made up of? Well, atoms are made up of protons, neutrons, and electrons. Protons are positively charged. Neutrons do not have a charge, and they are both found in the nucleus of the atom. And then electrons are found on the outside, surrounding the nucleus, and they are negatively charged. Now, all elements on the periodic table are made up of atoms, okay? The elements are defined by their atomic number. For example, magnesium is magnesium because the atom contains 12 protons. If the number of protons was to change, it would change the element and thus its properties as well. So as we can see on the periodic table, this top number here is the atomic number, and that refers to the number of protons. As you can see, for all the elements, the atomic number is different, thus defining the element, okay? The bottom number here is the mass number, and that's the total number of the number of protons and the number of neutrons. So if you want to find out the number of neutrons, all you have to do is subtract the atomic number from the mass number to find the difference, which is the number of neutrons. Now, because the number of protons is the same as the number of electrons, atoms overall do not have a charge unless it is an ion. So ions occur when the atom becomes charged when one or more electron is either lost or gained. Here are some examples. If you lose 2 electrons, you have a calcium 2 plus ion, because now you've got 2 less electrons than protons, vice versa. If you gain 3 electrons, you have 3 more, so you have a 3 minus charge. The mass number for ions is the same as mass number for atoms, because electrons don't really affect the mass. Now, electrons are arranged in shells, which refers to the space where electrons are more likely to be found. And these shells are composed of one or more subshell, which are groups of atomic orbitals. Each individual orbital can hold up to 2 electrons. So we have an s subshell, p subshell, and d subshell. So the first shell, which we'd call 1, closest to the nucleus, has an s energy level subshell. The s subshell only has 1 orbital, which can hold 2 electrons. So for example, hydrogen only has 1 electron, so you'd find that in the 1s subshell. And then we'd write the 1 for the number of electrons here. Helium has 2 electrons, so we'd find that in the 1s subshell with 2 electrons. The next subshell, which we'd call 2, has a 2s and a 2p subshell, which is why the number 2 is there. The p can hold up to 6 electrons because it contains 3 orbitals, 2 electrons in each. Boron, as an example, has 5 electrons, so its first 2 electrons will be in the first energy level, so we would write it as 1s2, 2 electrons. The second shell has an s and p subshell, so the s subshell holds another 2 electrons, and then the p is left with the last 3, so we'd write it, the electronic configuration, as 1s2, 2s2, and 2p3. The third shell now, shell 3, has an s, p, and d subshell. Okay, so d subshells can hold up to 10 electrons, as it consists of 5 orbitals, each holding 2 electrons. Sulfur, as an example, has 16 electrons, so we can start seeing it going into the third subshell, the third shell here. 1s2, 2s2, 2p6. Remember, p can hold up to 6. 3s2, 3p4. Now, let's look at some of the d subshells now. Well, we said 3d can hold up to 10 electrons, so why is this not 3d10 when it comes to nickel? Well, that's because, as you can see in this diagram, when we get to 3p, it actually fills the 4s subshell before the 3d subshell, and that's because it has a lower energy level than the 3d, and that's why the 4s2 gets filled up first, and then the remaining electrons fall in the 3d subshell. Now, there are some exceptions in copper's case, where it is more stable for the atom to complete its 5 orbitals and have a 4s1 than to have a 3d9 and then 4s2. It's more stable to do it this way, okay? And then we have an example for krypton here. So here are some questions, and here are the answers. So the atomic number for an atom that has 7 electrons is 7, because the number of, as long as it's not charged, the number is the same for protons and electrons. What is the number of neutrons for gold? Well, just subtract the atomic number from the mass number to get your neutron number. Just use your periodic table. How many electrons are in a chloride minus ion? 16 electrons, because chlorine has 15 electrons. You gain 1, you get 16. What is the electronic configuration for Zn2+? Remember, it's lost 2 electrons, so we end up with this configuration. And what is the electronic configuration for rhodium? Well, this is its configuration. Just remember to fill the 5s1 before the 4d8, but in this case it's an exception because it's more stable to complete its 4d subshell. Okay, any questions, just ask. Thank you for watching.